Okay, Wildcats. Today we're looking at Monday, March 26th, logarithmic transformations on page 66. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. Logarithmic transformations on page 66. So again, we're looking at the same kind of format for transformations. When a negative is in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the b, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. You would update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, now before you get started, you're going to need 3 colors. I would recommend 2 colors and then a black. Okay, the black's going to be for the asymptotes, and then the yellow and the green are going to be for the graphs. All right, so I'm actually going to graph this function in yellow. All right, but let's find out the information first. So transformation, first off, it's down 5 units. Okay, the asymptote is y equals -5. The y-intercept, well, to find the y-intercept, we know x equals 0. So y equals 2 to the 0 power minus 5, which equals -4. So the y-intercept is 0, -4. All right, domain we know is -infinity to +infinity. And then the range is from -5 to infinity. All right, so to graph this, we start with the asymptote. So we have an asymptote at y equals -5. Okay, now let's graph the y-intercept, which is at 0, -4. All right, so we know that for an exponential, it follows the asymptote and goes up. So there's your curve. Now we're going to graph the inverse, okay? But before you graph the inverse, do you know that the inverse reflects over the y equals x line? So let's graph the y equals x line before we get into the inverse, okay? So we know y equals x is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. So there's your y equals x line. So we know that the inverse should reflect over this line, okay? So it says the inverse, so the inverse of an exponential is a logarithmic. Function, okay? Now, we know from inverses that the x and y switches, or the asymptote switch, and the point x and y value switch, the domain and range switch. So the key word is switch. So you just might write that down as a reminder, switch. Okay? So let's start with the asymptote. So the asymptote was y equals -5. Now it is the x. So x equals -5. The point was, well, the only point we have so far is the y-intercept. We know that 0, -4. Well, if we switch the x and y values, it's -4, comma 0. And we're going to do this in green. And we're switching everything. Key is because of the inverse. Okay, so domain and range switch. So the domain was -infinity to +infinity. So now the range is -infinity to positive infinity. And then the range was -5 to infinity. Now the domain is -5 to infinity. Okay, so now we're going to graph first the x equals -5 asymptote. And the point -4, 0. Now, for a log, it actually comes up and curves. So it's going to go here. And you can see that these reflect over the y equals x line, so we've graphed the inverse correctly. All right, so now let's take a look at example 2. Again, we're going to graph this in yellow. But before we do that, let's find the transformations. So the transformations are right 1 unit, and up 3 units. Okay, so the asymptote is y equals 3. Now, for the y-intercept, we know that x equals 0. So that's f of 0 equals 2, 0 minus 1 plus 3, which equals 3.5. So the point is 0, 3.5. Okay, so domain we know is -infinity to positive infinity. And the range has to do with the asymptote. So it's 3, so the range is 3 to infinity. Now we have the information. Let's go ahead and graph. So let's first graph the asymptote, which is at y equals 3. Okay, so now the next part is the y-intercept, which is 0, 3.5, which is about right here. And so we know with an exponential that the curve is this. Now, before we get into the inverse, we want to graph the y equals x line because we know that the inverses reflect the y equals x line. So we know y equals x is 0, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. So now you have your y equals x line. So now let's get into the inverse. Well, we know the inverse of an exponential is a logarithmic function. Okay, and we're going to graph the inverse in green. Okay, now again, the keyword is switch. Okay, keyword is switch, so we're going to switch. The asymptote was y equals 3, now it's x equals 3. The point was 0, 3.5, now the point is 3.50. The domain was -infinity to positive infinity, now the range is -infinity to positive infinity. And the range was 3 to infinity, now the domain is 3 to infinity. So now let's graph the inverse. So first let's graph x equals 3. So 1, 2, 3. Okay. Now let's graph the point 3.50. Now for logs we know it goes up in curves. So here you can see that it reflects over the y equals x line. So we have the inverse. All right, go ahead and finish up example 1 and 2. All right, so now let's take a look at example 3. All right, so let's first look at the transformation. So the transformations are, in this case, right 6 units. And then up 4 units. Now we did go from exponential to log. Now, or where the exponential we graphed, and then the inverse was logarithmic. Now we're going to graph logarithmic, and the inverse is going to be exponential. Now with logarithmics, the asymptote's at y equals 0. So any horizontal shift moves that asymptote. Since we moved it right 16, the asymptote is now at y equals 6. I'm sorry, x equals 6, because it's a vertical. All right, so now key point, in this case, let's graph the asymptote first. So x equals 6. So now the reason why we do this is for this reason. You see, because the graph is going to be to the right of the asymptote, we will not have a y-intercept. So to get a point, we're going to pick the next point we can to the right of the asymptote. So in this case, let's use x equals 7. Okay, so we're going to now substitute 7 in for x, so that's y equals log base 2 of 7 minus 6 plus 4, and that's going to equal 4. So your point is 7, 4. So 7, 1, 2, 3, 4. Now domain for logarithmics is still negative infinity to positive infinity. Oh, actually, no. It switches. I'm sorry. It's different than the exponential. The domain here is going to be from 7, I'm sorry, starting at the asymptote, 6 to infinity. Okay, and then the range is negative infinity to positive infinity. So with exponentials, the domain is always negative infinity to positive infinity, but in logarithmics, the range is always negative infinity to positive infinity. All right, so let's go ahead and graph that. And we're going to graph it in yellow. So it's going to be here. Okay. Now, the inverse of a logarithmic is an exponential function. Okay. So again, keyword switch. You switch all the information. So the asymptote was x equals 6. Now it's y equals 6. Now the point was 7, 4. Now the point will be 4, 7. And the domain was 6 to infinity. Now the range will be 6 to infinity. And then the range was negative infinity to positive infinity. Now the domain will be negative infinity to positive infinity. We're doing this because we're doing the inverse. We're going to do the inverse in green. All right, so let's graph. So let's first graph the asymptote, y equals 6. And I almost forgot, let me take a step back. You want to graph the y equals x line before you start graphing anything. So let's do that first. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. You don't technically have to do it first, but I like doing it because I know I'm doing it correctly if these reflect over each other. All right, so now we have the asymptote, the y equals x line. Now let's graph the point. So point's 4, 7. So 4, 1, 2, 3, 4, 5, 6, 7. Now, we know the exponential goes horizontal, then vertical. And you can see that these reflect over the y equals x line, so we've done it correctly. All right, so now, if you would, finish up example 3, and let's take a look at example 4. All right, now, before I do example 4, just know that it's probably the more difficult of the 4 examples, so if you want me to do it again in class, let me know. All right, so transformation. It reflects the x-axis. Okay, and then it's going to go left 4 units. Okay, now remember with logarithmics, the asymptote has to do with horizontal or vertical asymptote. So here it would be x equals 0, but since it's shifted left 4 units, it's going to be x equals -4. Okay, so, and let's go and do that. Let's graph the x equals -4 asymptote. Okay, and the reason why I do it first with logarithmics is because Now you can see here, it is going to have a y-intercept, so we could use the x equals 0 value. So key point x equals 0. You could technically use any of these points, but 0 is usually the easiest point to work with. So x equals 0, so then that's y equals negative log base 2 of 0 plus 4, which equals negative 2. So your key point is 0, negative 2. Okay, domain we know is from negative 4 to infinity, and the range is going to be from negative infinity to positive infinity. Now, we know with log it's like this, but we reflected, so it's going to go like this. Now, remember, because you know that the inverse reflects the y equals x line, let's do that next. Let's graph y equals x. All right. So now we know the inverse of a logarithmic is an exponential. And again, the key word is switch. So the asymptote was x equals negative 4. Now it will be y equals negative 4. And the point was 0, negative 2. Now the point will be negative 2, 0. Now, the domain was negative 4 to infinity. Now the range will be negative 4 to infinity. And the range was negative infinity to positive infinity. Now the domain will be negative infinity to positive infinity. All right, so let's graph. So let's graph the asymptote first. So y equals negative 4. And let's graph the point negative 2, 0. All right, now, in this case, it's a little questionable of where the graph is going to be. So what I recommend doing is another test point. Probably some point over here, because that's going to tell you kind of how the curve is going to move. So let's just use like when x equals 2. So when x equals 2, that's y equals negative log base 2 of 2 plus 4, which equals negative 2.585. So negative 2.585. So the point would be negative 2, negative 2 point, so it's here. So that tells us the curve is moving kind of there. And you can see that they reflect over the y equals x line, so we have the inverse and the log graph correctly. All right, so at this point, if you understood all the examples, then start working on an assignment. If you didn't, then I'll go over the examples and the assignment in class if you need to. Okay, so with that, have a wonderful Wildcat day.